Hello friends, today is 19th lecture on electrostatic potential and capacitance, and today we shall solve some problems on capacitor. First problem, when two capacitors C1 and C2 connected in series, their equivalent capacitance is 2 microfarad, and when the same capacitors are connected in parallel, their equivalent capacitance is 9 microfarad. Then find individual capacitances, that is C1 and C2. Consider two capacitors C1 and C2 connected in parallel, and for parallel combination equivalent capacitance Cp is equal to C1 plus C2, but Cp equal to 9 microfarad, or it can be written as C1 plus C2 is equal to 9 microfarad, since Cp equal to 9 microfarad. And when these capacitors are connected in series, then their equivalent capacitance is Cs, and for two capacitors Cs equal to C1 C2 upon C1 plus C2, or this can be written as C1 C2 is equal to Cs in the bracket C1 plus C2. That is C1 C2 equal to Cs is given, Cs equal to 2 microfarad, that is 2 into 10 to the power minus 6 into C1 plus C2, but C1 plus C2 equal to 9 microfarad, that is 9 into 10 to the power minus 6 farad, and that is equal to 18 into 10 to the power minus 6 minus 12. C1 C2 equal to 18 into 10 to the power minus 12. Now we know that C1 minus C2 is square is equal to C1 plus C2 whole square minus 4 C1 C2, and C1 minus C2 whole square equal to, here C1 plus C2 equal to 9 microfarad, that is 9 into 10 to the power minus 6 square minus 4 into C1 C2 equal to 18 into 10 to the power minus 12, that is equal to 9 square 81 into 10 to the power minus 12 minus 18 into 4 72 into 10 to the power minus 12. That is equal to, here 10 raised to minus 12 is common, 81 minus 72 is equal to 9. 9 into 10 to the power minus 12. That is C1 minus C2 whole square is equal to 9 into 10 to the power minus 12. Therefore, taking square root on both sides, that is C1 minus C2 is equal to square root of 9 is 3 into square root of 10 to the power minus 12 is 10 raised to minus 6. We know that here C1 plus C2 equal to 9 microfarad and C1 minus C2 equal to 3 microfarad. Therefore, solving these two equations, that is adding add or subtract, adding, take it as equation 1 and this as equation 2, adding 1 and 2, that is C1 plus C2 is equal to 9 microfarad and C1 minus C2 is equal to 3 microfarad. Adding these two, plus C2 minus C2 get cancelled. C1 plus C1, 2 C1 is equal to 12 microfarad. Therefore, C1 equal to, therefore C1 is equal to 12 divided by 2 is equal to 6 microfarad. And substituting the value of C1 either in equation 1 or equation 2, we get the value of C2. Or substitute the value of C1 in equation 1, we get from 1 C1 plus C2 is equal to 9 microfarad. Therefore, C2 is equal to 9 microfarad minus 6 microfarad. That is 9 microfarad minus C1. Here C1 equal to 9 minus 6 common microfarad, that is equal to 3 microfarad. Hence C1 equal to 6 microfarad and C2 equal to 3 microfarad. These are capacitances of individual capacitors, right? And for parallel combination, Cp equal to C1 plus C2. C1 equal to 6 microfarad, C2 equal to 3 microfarad, that is 6 plus 3 is equal to 9 microfarad. And Cs equal to 6 into 3, 18 divided by 6 plus 3, 9. 18 divided by 9 is equal to 2 microfarad. Clear? And next number 2, the energy stored in the combination of two capacitors when connected in parallel is 45 joules. Energy stored in the two capacitors when they are connected in parallel is 45 joule, and the energy stored in the same capacitors when they are connected in series is 4.05 joules at potential 3000 volt. Then find individual capacitances. Let C1 and C2 be the capacitances of two capacitors. Then energy stored when they are connected in parallel. Solution: energy stored is given by U equal to half CV square or Q square upon 2C or half QV. Here we use U equal to half CV square, and here C is equivalent capacitance of capacitors when connected in parallel. Therefore, energy stored when two capacitors are connected in parallel is equal to half equivalent capacitance of two capacitors connected in parallel, that is Cp, and Cp equal to, we know that, C1 plus C2. This is the equivalent capacitance of two capacitors connected in parallel into phi square, that is equal to, but Up equal to energy stored when they are connected in parallel is 45 joule, that is equal to 1 upon 2 C1 plus C2, these are unknown, into phi square, where phi is 3000 volt. 3000 square, that is equal to 45 into 2, 90, is equal to C1 plus C2 into 3000 square is 3 square 9, and square of 1000 is 1 after 6 zeros, because square of a 0 is equal to double 0, square of 2 zeros is 4 0, square of 3 zeros is 6 0, 1 after 6 zeros. Hence it can be written as 9 into 10 to the power 6, 3000 square is equal to 9 into 10 raised to 6. Therefore, C1 plus C2 is equal to 10 into 10 to the power minus 6, because 90 divided by 9 into 10 raised to 6, it can be written as, that is 9 ones are 9 tens are 10 into 10 to the power minus 6. This is equal to Cp, and energy stored when two capacitors connected in series is Us equal to half Cs into phi square, Cs into phi square, that is equal to, here Us equal to 4.05 is equal to 1 upon 2 into Cs is given by C1 C2 divided by C1 plus C2. For two capacitors C1 and C2, their equivalent capacitance Cs equal to C1 C2 upon C1 plus C2 into phi square, where phi equal to 3000, and the square of 3000 is 9 into 10 to the power 6, 10 to the power 6. Now 4.05 into 2 is equal to 8.1 is equal to C1 C2 upon C1 plus C2 into 9 into 10 raised to 6 can be written as divided by 9 into 10 to the power 6, and 8.1 divided by 9 is equal to 0.9 or 9. 8.1 divided by 9 is equal to 0.9. 0.9 into 10 to the power minus 6 is into C1 C2. C1 plus C2, but C1 plus C2 equal to 10 into 10 to the power minus 6 into 10 into 10 to the power minus 6 is equal to C1 C2. 8.1 divided by 9 is equal to 0.9 into 10 to the power minus 6 into C1 plus C2, but C1 plus C2 equal to 10 into 10 to the power minus 6, and that is equal to 9 into 10 to the power minus 12 is equal to C1 C2. Now we can use C1 minus C2 whole square equal to C1 plus C2 whole square minus 4 C1 C2. Now consider this as equation 2 and this as equation 1. C1 plus C2 equal to, and this is C1 C2 equal to. Now using C1 minus C2 whole square is equal to C1 plus C2 whole square minus 4 C1 C2, that is equal to, here C1 plus C2 equal to 10 into 10 to the power minus 6 minus 4 into C1 C2 equal to 9 into 10 to the power minus 12. 9 into 10 to the power minus 12, that is equal to minus 6 minus 6 12. 9 into 4 36, C1 plus C2 equal to 10 into 10 raised to minus 6, this square minus 10 square is 100 into 10 to the power minus 12 minus 36 into 10 to the power minus 12, that is equal to 100 minus 36 is equal to 64 into 10 to the power minus 12. 10 raised to minus 12 is common here, therefore C1 minus C2 whole square is equal to 64 into 10 to the power minus 12. Taking square root on both sides, take down this, stop the video and take it up. Taking square root, we get C1 minus C2 is equal to square root of 64, 8 into 10 to the power minus 6. and we know that C1 plus C2 equal to 10 into 10 to the power minus 6. Consider this as equation 3. Adding 1 and 3. Equation 1 is C1 plus C2 is equal to 10 into 10 to the power minus 6, and C1 minus C2 is equal to 8 into 10 to the power minus 6. Adding, we get plus 6 C2 minus C2 get cancelled. That is, we get 2C1 is equal to 18 into 10 to the power minus 6. Therefore, C1 is equal to 9 into 10 to the power minus 6 farad. Now, substitute the value of C1 in equation 1. We know that C1 plus C2 is equal to 10 into 10 to the power minus 6. We know that C1. Therefore, C2 is equal to 10 into 10 to the power minus 6 minus C1. That is equal to 10 into 10 to the power minus 6 minus C1 equal to 9 into 10 to the power minus 6. That is equal to 10 minus 9, 1 into 10 to the power minus 6 farad. Therefore, C1 equal to 9 into 10 raised to minus 6 farad, or that is equal to 9 microfarad, and 1 into 10 to the power minus 6 farad is equal to 1 microfarad. Hence, individual capacitances are C1 equal to 9 into 10 raised to minus 6 farad and C2 equal to 1 into 10 to the power minus 6 farad. Next, 6 microfarad capacitor is charged at 150 volt potential, and the potential decreases to 90 volt when another capacitor is connected. Then find the second capacitance of second capacitor, and also find the energy lost due to the connection. And here, two capacitors when connected C1 and C2, their potential decreases to 90 volt. Therefore, the common potential due to two capacitors C1 and C2 is given by, or here first given C1 is equal to 6 microfarad and it is at potential V1 is equal to 150 volt. Find C2. Find C2 and V be the common potential and V2 is the potential of C2. It is uncharged, therefore its potential phi2 equal to 0, and common potential phi is equal to 90 volt. But the common potential is given by common potential of two capacitors is given by phi equal to C1 V1 plus C2 V2 upon C1 plus C2. The common potential of two capacitors connected can be found out by using phi equal to C1 V1 plus C2 V2 upon C1 plus C2. And here common potential phi equal to 90 volt, that is equal to C1 is 6 into 10 to the power minus 6 into V1 is 150 plus phi2 equal to 0, hence C2 phi2 equal to 0 divided by C1 plus C2, 6 into 10 to the power minus 6 plus C2. Now cross multiplying, we get 90 into 6, 540 into 10 to the power minus 6 plus 90 C2, that is equal to 6 into 150, 900 into 10 to the power minus 6. Here 0 get cancelled. Next 90 C2 is equal to 90 minus 54. Here 10 raised to minus 6 is common outside. Therefore C2 is equal to 90 minus 54. 90 minus 54, 36 into 10 to the power minus 6 divided by 90, that is equal to 90 C2. 36 divided by 90. Cancel. Here 900 minus 540 into 10 to the power minus 6, that is equal to 900 minus 540, 360 into 10 to the power minus 6 divided by 90, that is equal to 4 into 10 to the power minus 6 farad or 4 microfarad. Here C1 equal to 6 microfarad given and C2 equal to 4 microfarad. Then what is the loss in the energy? First find initial energy when only C1 is present. Take down. initial energy UI is equal to half C1 P square. C1 P square, that is equal to half C1 equal to 6 into 10 to the power minus 6 into 150 square, that is equal to 2 ones are 2 threes are 3 into 10 raised to minus 6 into 150 square, 225. Is it correct? Square 150 into 150, 22,500. Correct? And solving this, we get 3 into 22,500 is equal to 675 00 into 10 to the power minus 6, and that is equal to 6.7 into 75 into 10 to the power minus 2 joules. Then find the final energy when two capacitors connected C1 and C2. Try, that is final energy UF equal to. For one capacitor C1 P square, if another capacitor is connected, then UF equal to half C1 plus C2 into their common potential P square. Half C1 P1 square, it is half C1 plus C2 into P square, that is equal to 1 upon 2. C1 is 6 plus C2 equal to 4 microfarad, 10 raised to minus 6 into common potential 90 square, that is equal to 6 plus 4, 10, 10 by 2 equal to 5 into 10 to the power minus 6 into 90 square, 9 square 81, and 0 square 00. Now multiplying 5 into 81, 5 into 81 equal to 405, that is equal to 405 into 8100, that is equal to 40500 into 10 to the power minus 6, that is equal to, it can be written as 4.05 into 10 to the power minus 2 joules. Initial energy is 6.75 and final energy when they are connected is 4.05. Therefore loss in energy, therefore loss in energy, loss in energy is delta U equal to UI initial energy minus final energy. That is equal to initial energy is 6.75 into 10 to the power minus 2 minus final energy is 4.05. Here common 10 raised to minus 2. That is equal to 6.75 minus 4.05 is equal to 2.7. 2.7 into 10 to the power minus 2 joules of energy is lost, or it can be written as 0.0227 or 03 joules. This is the loss in energy. Next, number 4. The given network consists of capacitors connected in parallel and series. Find the equivalent capacitance of the network. Here, two capacitors, each of capacitance 3 microfarad, are connected in parallel, and 1 microfarad and 2 microfarad capacitors are connected in parallel, and these combinations are connected in series. Therefore, find equivalent capacitance of parallel combination. Number 1, 2 3 microfarad are connected in parallel. Therefore, their equivalent capacitance is C1 is equal to CP1 is equal to C1 plus C2, and that is equal to 3 plus 3 microfarad, that is equal to 6 microfarad. And here 1 microfarad and 2 microfarad are connected in parallel. 1 and 2 microfarad are parallel. Therefore, their equivalent resistance in parallel combination is CP2, that is equal to C1 plus C2. Here C1 equal to 1 microfarad and C2 equal to 2 microfarad, that is 1 plus 2 microfarad, that is equal to 3 microfarad. Now, these combinations are in series. Therefore, number 3, CS is equal to, that is CP1 and CP2, they are in parallel. Therefore, CS equal to CP1 plus CP2, CP1 into CP2 upon CP1 plus CP2, because we know that CS equal to C1 C2 divided by C1 plus C2. Here C1 equal to CP1 and C2 equal to CP2, and that is equal to Cp1 is 6 into 10 raised to minus 6 into Cp2 is 3 microfarad. 3 into 10 to the power minus 6 divided by 6 plus 3, that is 9 into 10 to the power minus 6. That is Cs is equal to 6 into 3, 18 into 10 raised to minus 12. 18 into 10 to the power minus 12 divided by 9 into 10 to the power minus 6, that is equal to 2 into 10 to the power minus 6 farad. The equivalent capacitance of these two combinations in series is Cs is equal to 2 microfarad. Now this Cs, that means the combination of these two capacitors and these two capacitors in series is equal to 2 microfarad, and hence the equivalent capacitance of these capacitors is in parallel with 2 microfarad. And next step is here Cs and 2 microfarad are parallel. Therefore, for parallel combination, Cp equal to Cs is Cp equal to Cs into 2 microfarad, that is 2 into 10 raised to minus 6 divided by Cs plus 2 into 10 to the power minus 6, that is they are connected in parallel. Therefore, for parallel combination, Cp equal to C1 plus C2, that is C1 is Cs plus 2 microfarad, but Cs equal to 2 into 10 to the power minus 6 plus 2 into 10 to the power minus 6, that is equal to 4 into 10 to the power minus 6 farad. Therefore, equivalent capacitance in parallel combination is 4 microfarad or 4 into 10 to the power minus 6 farad. Then find the energy stored in the combination. The energy stored in the combination is equal to the energy stored in equivalent capacitor. And number 5, energy stored. U equal to half CV square, where CV is Cp. C is Cp into P square, that is equal to 1 upon 2 into Cp is 4 into 10 to the power minus 6 into P equal to 100 volt, and 100 square is equal to 1 after 4 zeros, and can be written as 10 into 10 raised to 3, or 1 into 10 raised to 4, and that is equal to 2 ones are 2 twos are, that is 2 into 10, 20 into 10 raised to minus 3, or better you write it as 10 raised to 4. 100 square is equal to 10 raised to 4 into 10 raised to minus 6 plus 4, minus 2 joule, or it can be written as 0.02 joule. This much of energy is stored in the equivalent capacitor or in the circuit.